So the next problem is all about the L'Hopital's rule. So without further ado, let's move to the problem. Limit of sin x minus x over x squared as x approaches to 0. So as x approaches to 0, both numerator and the denominator approach 0. So therefore, we need or we can apply L'Hopital's rule. So in this case, we obtain limit of sin x minus x over x squared as x approaches to 0. So this would result to cosine x is 1 over 2x. So if you are questioning this, the technique is that you need to derive this. Okay? So since the numerator and the denominator of this new quotient both approach 0, we apply L'Hopital rule again. So in doing, we see that limit of cosine x minus 1 over 2x as x approaches to 0 can be simplified into negative sin x over 2, which is also equal to 0. So therefore, we conclude that limit of sin x minus x, this is over x squared as x approaches to 0 is equal to 0. So this is the final answer.
Okay.
So the second problem for finding a derivative using L'Hopital rule. So given the problem, limit of 3x plus 5 over 2x plus 1 as x approaches to infinity. So since 3x plus 5 and 2x plus 1 are having a first degree polynomials with positive leading coefficients, so it will result to limit of 3x plus 5 as x approaches to infinity is equal to infinity, and limit of 2x plus 1 as x approaches to infinity is also equal to infinity. So therefore, we apply L'Hopital rule and obtain limit of 3x plus 5 over 2x plus 1 as x approaches to infinity. So we can obtain with limit of 3 halves as x approaches to infinity. Note that this limit can also be calculated without invoking L'Hopital rule. So earlier, we showed how to evaluate such limit by dividing the numerator and the denominator by the highest power of x in the denominator. So the final process for this is equal to limit of 3x plus 5 over x over 2x plus 1 over x as x approaches to infinity by the use of L'Hopital rule. So this would simply give us 3 halves. So this is the final answer.